Hello everyone, I am Prem Kumar. Welcome to Math JEE Academy. So today I am going to discuss with you very interesting topic: number of one-one functions, number of onto functions. First we will discuss the basic idea of the functions and how to describe the one-one functions and onto functions. How many functions you can able to find out. So all the things one shot video we can discuss. Okay. So if you not yet subscribe my channel Math JEE Academy, please subscribe it. So once you watch my concept, you can be able to understand step by step, the explanations, right? Okay, let's get started the today topic. Okay, the number of onto functions, one functions. Before that, we'll discuss the what is mean by functions, what is one functions, what is onto functions, what is many one functions, what is into functions, what is bijective functions. Everything we have to analyze step by step. Okay. So the first thing is what is mean by functions. The many of the students are facing difficulty the functions ideas, right? Just like you can see, you can imagine this is your machine, right? Let us take F is the machine. If I put inside here X, then you can see if you take this input here, the output is under the process of F, so you'll get F of X, right? So you can take this is along the x-axis, here this along this y-axis. This is, you can say that input, this is output. This is, you can say input, this is output, right? Just you can take it as along the x-axis, this is along the y-axis. Clear? Okay. So is there any conditions for the set? Any conditions for the functions are there or not? You can see. Let us take A is equal to 1, 2. B is equal to, let's take AB, you can take. First you can find the all possible order pairs. What is that? A cross B. So 1 comma A, 1 comma B, 2 comma A, 2 comma B. Clear? These are the all possible order pairs. Clear? Okay. The function is, first of all, it is subset of A cross B. A cross B is what? Cartesian product of A and B. Okay. Let us take, if you consider F, even though if you consider this A cross B as the F, this is not a function. Then what is the conditions for the functions? First of all, it should be, function should be subset of A cross B. What is subset? So A is a subset of B means, you can see, if A is a subset of B means every element in A will be there in B. That means A is a subset of B here. Understand? Okay. So once you understand the subset idea, but you can see F you considering A cross B, this is not a function. Is there any condition is there for function? Yes, it is there. The first thing is, you can see the first set is there, no, A is there, you consider as a domain, and B you consider as a codomain, right? Okay. First you can see, let us take here is A is what? 1, 2, and B here is, this is A, this is B, this is AB, right? But it is, if you consider this is F, why it is not a function? The conditions for the function is, the first is every input has, every input here is X, has single output. Okay, that means if you pick one element, corresponding one element only will get. If one element has two output means it's not a function, right? Second one, all the input has the output, right? All the input has output. Clear? All the input has output. If one element in the domain does not have the image, it is not a functions. Understand? The first thing, if you pick one element, you will get one output. If there is no element, suppose if you consider the input, if one element does not have the output, that is also not a functions. If both condition is satisfied simultaneously, then only we can say it is a functions, right? Okay, but why this A cross B is not a function? Because you can see one input, x coordinate you can consider as input, y coordinate you consider the range, right? So one goes to A, one goes to B. One input has two output is there. 2 goes to A, 2 goes to B. 2 is one input, then you have two output is there. It's not a function. Okay? Fine. Then you understand the idea, right? The functions, right? Let us take the function from a real number to real number. F of x equal to x square you can take. This is a parabola, right? X axis, this is y axis. Your domain is a real number, range also real number, right? So you already know that it is the parabola, right? It's a y is equal to x square. This is the function or not? Yes, it is a function because every input has a single output here. Then how to understand graphically? If you draw anywhere in the graph, right? Draw the vertical line anywhere in the graph. It crosses the graph at most one point. Then it is a function. That means one input has the one output, right? Let us take a second example. Suppose f of x equal to, let's take another way. Suppose if you consider this way, x comma y such that x square plus y square is equal to 4 you consider. Okay, if you consider this one, this is not function or not. How to check it? You can see, student, first one thing you can observe that y square is equal to 4 minus x square. So then y is equal to plus or minus 4 minus x square, right? If you put x is equal to 0, because x may be any real number, so you consider this is belongs to r cross r, right? If x is equal to 0, put x is equal to 0, what is the y value? Y is equal to plus or minus 2. So one input has two output here. One input you are taking 0, you are getting 2 and minus 2. This is not a function. Then how to draw the graph of this? You can see this is the circle with radius is 2. This is 2 comma 0. This is minus 2 comma 0. This is 0 comma 2. This is 0 comma minus 2. Draw the circle around it. Okay. This is the circle with radius 2. Okay. If you draw the vertical line, you can see this is x. This is your x comma f of x. This is your x comma minus f of x. Is a negative y, right? So here one input has two output is there. So if you write in the set order pair, how to write it? Let's take A, you can consider x comma f of x, and same x, it's negative f of x, right? So this is not a function. Why? Because one input has the two output is there, y and minus y is there. Understand? This is not a function, right? The function has if you draw the vertical line, no, so it crosses the graph at most one point, but here is more than one point is there, therefore it is not a function, right? Okay, function we discussed. Next we will discuss the what is mean by one function, what is onto functions. Okay, let us take one functions, one-to-one functions. So one-to-one function has a distinct element, has distinct images, right? You can see if I take A, let us take 1, 2, 3. Let's take B, A, B, C you can take. So 1 goes to A, 2 goes to B, 3 goes to C. This is 1, 1 function, right? Suppose if I consider, so 1, 2, 3, let's take R1, R2, R3 you can take. 1 goes to A, 1 goes to R, 1 goes to R2, 2 goes to R, 3 goes to R3. First of all, it is not a function. Why? One input has two output is there. This is not a functions. And the same way, you can see distinct element has distinct image. Not there. This is not a function. This is not at all a function. So we cannot discuss about the 1, 1 functions, right? Okay. So what is the conditions? What is the condition is required for the 1, 1 functions? So what way we can describe it? Okay. We'll discuss this. First, we'll use the definition. The best part of the definition you can see, distinct element has distinct element in domain has distinct images. Images means output value, ranges. Distinct element in the domain has distinct images. Okay, that means what? If I consider here, let x1 and x2 belongs to, let's take A, is the domain. Okay, if image is equal, distinct elements here, image is equal means, so definitely the points also equal, right? This is 1, 1 definitions. Pick two elements in the domain, you check that the images are different images. F of x1 is same as f of x2 means the x1 should be equal to x2. This is the, so equivalently how to write contrapositive. This implies f of x1 equal to f of x2 means x1 is equal to x2 we can say. The contrapositive, what is the contrapositive? If x1 not equal to x2 means f of x1 is not equal to f of x2. Clear? Two distinct element you take, the image also not equal. Elements are distinct, the image also distinct. Then it is 1, 1 functions. If this statement is true, then automatically this statement is true. This statement is not true, then automatically this statement also not true. This is a contrapositive, right? Okay. Then what is the definition for not 1, 1 functions? Not 1, 1. This is 1, 1, right? Not 1, 1 means what? If I pick two elements in the domain, let's take A, that elements are not equal, but it implies f of x1 is equal to f of x2, right? Two distinct element you take or distinct, but image would be same. Let us take example, f of x equal to x square, the function from real number to real number you take, okay? But you can see when you draw the graph of this is your x square graph, right? When you take this graph x square, y is equal to x square graph. But you can take here, this is -1, this is +1. -1 is not equal to 1. But when you apply f of 1, what is that? X square, right? If you apply that, 1 square is 1. F of -1 you can apply, -1 whole square, that is also 1. But here, f of -1 equal to f of 1. The two distinct element, but the same image. Therefore, it is not 1, 1 functions, right? Then how to pictorially represent this one? Just you can draw horizontal line. Horizontal line test will help you to identify whether the function is 1, 1 or not. If the horizontal line cross the graph at most one point means it's 1 functions. Here is more than one point is crossing, therefore it's not 1 functions, right? So you can see this is your horizontal test. Horizontal test will help you to identify the graph, right? It is 1 function satisfy or not. 1 or not, how to check it? Draw a vertical line. Sorry, draw horizontal line anywhere in the graph. It crossed the graph at most one point. If more than one point it's crossing means it's not 1 functions. Clear? So definitely this is not 1 functions, right? Okay, let me take one example. F of x function from real number to real number. F of x equal to x divided by 1 plus x. You can take this function. This is 1 function or not? How to check it here? So one way is using the definition you can apply. F of x1 is equal to f of x2. You have to prove that x1 is equal to x2. Right? Let us take two elements. Let's take x1, x2 belongs to R. You can take. Domain here is what? R only, no? First assume that f of x1 is equal to f of x2. So f of x means x by 1 plus x. F of x1 means what? x1 divided by 1 plus x1. Here x2 by 1 plus x2. Okay. Cross multiply. x1 into 1 plus x2 is equal to x2 into 1 plus x1. You just multiply x1 plus x1 into x2 is equal to x2 plus x1 into x2. Clear? Okay. So then you can see, student, x1 plus x1 x2 minus x2 minus x1 x2 equal to 0. This will be cancelled. Then we can say that x1 equal to x2 can say. Right? We assume that f of x1 is equal to f of x2. But we prove that x1 is equal to x2, therefore it is 1 function, right? It is true for any real number. X1, x2 belongs to real number. Clear? Then how to check in another way? You can see, so when you take the function, suppose the function from real number to real number, okay? Suppose if I take f of x equal to 3x plus 4, you can take. So straight line, right? So when you draw the graph of this, you put x is 0, y will be 4. If y is 0, okay, x is 0 means y would be 4. If y is 0 means what? 3x equal to minus 4, x equal to minus 4 by 3. Clear? 3x equal to minus 4, x equal to minus 4 by 3. I hope everyone understand, right? So you draw the graph of this, a straight line, x-axis, y-axis, put x is 0, 4, 0 comma 4, where it is here, and minus 4 by 3, minus 1 point something, somewhere here, minus 4 by 3 comma 0. If you join these two points, this is your straight line. So you can see this is the positive slope, it is increasing, right? What is mean by increasing here? When you take, what is mean by increasing? When you take two numbers, let's take x1 and x2. Definitely x1 should be less than x2. You can represent the number line along the x-axis, right? x1 less than x2 means you can see the height of the this the height of this one will be f of x1. This is f of x1. This will be f of x2, right? So you can see the height will also change, increasing, right? Order. F of x1 is equal to f of x2. If x1 less than x2 means f of x1 also f of x2. What is the meaning? The input, two elements, if a 1 less than 2 means f of 1 also less than f of 2. That vertical height is also, it is increasing fashion. Understand? Okay. So why we need increasing functions? Whenever the increasing order is there, so increasing passion is there, either completely increasing or completely decreasing order. Then if you draw horizontal line, so definitely this function is what? 1 functions. Let me take one simple example. Let me take simple example. Here is f of x equal to, let us take f of x equal to sin x you can take. Okay. F of x equal to, let us take sin x is a function from real number to real number you take. You know the sin x graph? This is x axis, this is y axis. Clear? Let us take pi by 2. Sin pi by 2 is what? 1, right? Here is minus 1 you take. Sin pi will be 0, right? The graph will be going like this, right? This is the graph. The same way it will go like this. This is sin x graph, right? But when you draw the horizontal line, you can see when you draw horizontal line, this is not 1 functions. When it will be 1 functions? If you complete domain is a real number, it is not 1 functions. The sin x is not 1 functions. Why? Because if you draw horizontal line, it will be crossing more than 1 point, right? But 1 function is what? If you draw horizontal line anywhere in the graph, it crosses the graph at most 1 point, right? So therefore, you can say that this is not 1 function. How to restrict the domain? How to restrict the domain? The function is, you can see which interval, you can see student, which interval you can draw, okay, which interval you can draw horizontal line, it will cross the graph at most 1 point. You can see this is pi by 2, this will be minus pi by 2. If you take this interval, if you draw anywhere in the graph, right, in the close interval minus pi by 2, it will cross the graph at most 1 point. Definitely in this interval, it is increasing. Okay, that's why we need actually is completely increasing. We can say the function is 1, because you draw horizontal line, it will cross the graph at most 1 point. Okay, therefore the sign, if you take real number 2, you know the range is what? Minus 1 to 1. If you take this function, this is not 1, not 1, right? When you take the sign is from minus pi by 2 to pi by 2, the close interval minus 1 to 1. You take sine of minus pi by 2 is what? Minus 1, sine pi by 2 is what? 1. So 1 to 1 correspondent is there. That's why we are restricting the domain real number to minus pi by 2 to pi by 2. Then only the inverse exists. Inverse when it is exist? When inverse exists means it should be 1 correspondence is required. Okay. That's why we are restricting the domain from real number to minus pi by 2 to pi by 2. I hope everyone understand, right? So, therefore, the sin x is increasing when x is belongs to minus pi by 2 to pi by 2. Clear? F of x equal to sin x is increasing. I will put the arrow mark increasing on the my interval minus pi by 2 to pi by 2. Clear? Okay. So, let me take another example. Let me take f of x equal to x minus 1 into x minus 2, right? If you take this interval, if you take this functions, right? What is this function actually? If you multiply this second example, you can see x square minus 2x minus x plus 2, x square minus 2x minus x plus 2, that is x square minus 3x plus 2. This is your function. So this function is a 1 function or not? How to check it here? First, you can find the vertex of the parabola. when there is a parabola case, what you can do? You just find the roots of the equations. Roots means what? Solutions of the equation. When we can find the solutions when f of x equal to 0. Why we are equating 0? Because we need x value. The y values are 0 along the x axis. That's why we are equating to 0. Then we can find the solution x. Now you can equate to 0. We can find the solution x is equal to 1 and 2, right? Then vertex you can find out. Vertex is what? Minus b by 2a minus d by 4a. Okay. Minus b by 2a minus d is what? Discriminant. B square minus 4ac. So if you multiply minus 4ac, right? Minus b square. Correct? Divided by 4a. I hope everyone understand. B square minus 4ac. If I multiply minus inside, 4ac minus b square. Now you can substitute. What is b here? B is what? I am doing correct. X square minus 2x minus x plus 2. Yes, correct. B is minus 3. Minus of minus 3 whole divided by a is 1. And 4 into a is what? 1. And c here is what? 2 minus b square. B here is what? Minus 3 whole square, right? That is 9 divided by 4 into 1. Check it once. So minus into minus 3 by 2, right? Here is I am checking 1 and c is 2. Yes, correct. B square is correct only. 8 minus 9 is what? Minus 1 by 4. Clear? X coordinate is positive, y coordinate is negative. So which coordinate is possible here? You can see, let me take another page. Let me take here, the graph is x-axis, this one, y-axis. You can see the roots are what? 1 and 2, right? Roots are 1 here and 2 here. Let's take here 2. And then the vertex is what? 3 by 2, x is positive and y is negative. So 3 by 2 minus 1 by 4. 3 by 2 is what? 1.5. This is your point, right? 3 by 2 comma minus 1 by 4, right? This is your vertex. So the graph will be going like this. Where this graph is intersecting the y-axis, how to check it? You can see, student, put x is equal to 0. Put x is 0, we can find the y-intercept. 2, 0, comma 2, right? 0, comma 2. So x is positive, y is negative, means lies in the fourth quadrant. This is your graph. How to find the 1, 1 functions? Which interval this function is 1, 1 functions? That means which interval this function is increasing or decreasing, we have to find out, right? Okay. First you can see, when you take the functions f of x equal to what is given to you? X square minus 3x plus 2. X square minus 3x plus 2. You can differentiate this function. You already know that if the function is increasing, the first derivative of the functions will be greater than 0, increasing. Less than 0 means decreasing. The slope is positive, increasing. The slope is negative, decreasing, right? Okay. So if you differentiate this function, 2x minus 3, right? Understand? So first you can identify the critical points. Okay, equate to 0. What is that? 2x equal to 3, x equal to 3 by 2. You draw the number line. So 3 by 2. Okay. You can see the sign changes in the f dash of x, right? So 2x minus 3, no? If you less than 3 by 2, you can take any number. 3 by 2 means what? 1.5. If you take less than 3 by 2, let's take 0 you can take. You can apply f dash of, we need to find the sign changes of f dash of x, right? You put x 0, minus 3. So negative. Take more than 3 by 2. More than 3 by 2, let us take 2. 2 is 2 into 2 is 4. 4 minus 3, it is 1. It is positive. So therefore, which interval is positive, that is increasing? Which interval is negative, that is decreasing? So we can say that the function is increasing in the interval, which interval? X is belongs to 3 by 2 to infinity. So f is decreasing. You can see the arrow mark up means increasing, arrow mark down means decreasing. Increasing, decreasing. So x belongs to minus infinity to 3 by 2. Clear? You can see the graphically also. Graphically, you can see if you draw anywhere in the graph after 3 by 2, it is completely crossing the graph at most one point. If I take less than 3 by 2, take another color. If I take anywhere in the graph, it will be crossing at most one point, horizontal line. Definitely it is increasing. But if you consider the whole domain, whole interval, real number to real number, this function is not at all one function. But you can reduce it. You can restrict the domain. We make into the one functions. X square minus 3x plus 2, it's not 1 on the real number, but the function is 1 in the interval more than 3 by 2 also 1 functions, less than 3 by 2 also 1 functions, right? Because completely decreasing, less than 3 by 2, if more than 3 by 2 also it is increasing, therefore that is there also 1 function exists. Suppose if you say that the function is 1 function, means you have to check which interval the function is increasing or decreasing, you have to check. It should not be completely, both, right? Both is not possible. You cannot say whole interval is increasing, decreasing means it's not 1 function. Understood? It's completely increasing or completely decreasing. Okay, I hope everyone understand the 1 functions, right? Okay, so let me take one more example here. Suppose if I consider f of x equal to, suppose the functions from real number to real number. Okay, suppose you consider f of x equal to, so x plus 1 by x you can take. Okay, x plus 1 by x. This function is 1 functions are not in the real number, or not. How to check it? You can simplify this, x square plus 1 divided by x. Clear? You cross multiply x square plus 1 by x. Now you can differentiate this function f dash of x. You can u by v method. The quotient rule you can apply, right? First you can square the denominator. You keep the denominator as it is and differentiate the numerator. 2x, 1 differentiation is 0, minus x square plus 1 you can keep as it is, x differentiation 1. Clear? Keep the denominator as it is. Square the denominator and keep the denominator as it is and differentiate the numerator, minus keep the numerator as it is and differentiate the denominator. You can simplify this. This is 2x squared minus x square minus 1. Clear? Divided by x square. This implies we can say x square minus 1 by x square. Okay, I hope everyone understands this one, right? 2x square minus x square minus 1. 2x square minus x square is what? X square minus 1 divided by x square. This is your f dash of x. Okay, so now you can equate to 0. Equate to 0, x square already know that greater than 0. Then we can say that x square minus 1 equal to 0. from this x square is equal to 1. Therefore, x is equal to plus or minus 1. We got the critical points. Now you have to fill it on the number line. Take the another page. You can see here minus 1 here. This is plus 1. What is your f dash of x? You can see. What is your f dash of x? You can see, student, f dash of x is what? X square minus 1 by x square. X square minus 1 by x square. You check it once. Again, f dash of x is correct or not? Yes, correct only. Okay. So, yes, correct. Now you can check less than minus 1 you take. Less than minus 1. Which number you can take? Let's take minus 2. Minus 2 whole square minus 1 divided by minus 2 whole square. That is 4 minus 1 divided by 4. So, 4 minus 1 divided by 4, it will be 3 by 4. Okay, so definitely it is positive. Clear? So, in this interval, positive. There is no issue. Let's take minus 1 to 1. So, minus 1 to 1, which number you take? 0 you can take. F dash of 0 you can substitute. Minus 1 by 0. So, this is not defined, no? So, not defined. Let me take another value. Let's take 1 by 2 you can take here. Let me take 1 by 2. So, if I take 1 by 2, it will be 1 by 4 minus 1 divided by 1 by 2 whole square is what? 1 by 4, right? If I take this one, minus 3 by 4 divided by 1 by 4, clear? 1 minus 4, it is minus 3 by 4, 1 by 4. 4 cancel, then you will get negative. So, in this interval it is negative except 0. It is not defined, right? Okay. So, if I take here, if you put 0, it is not defined, right? Okay, that means you cannot take the x values, right? X value is equal to 0. So, next if I take more than 1, if I take any value, let us take 2, 4 minus 1. So, definitely the numerator is positive, denominator positive. So, therefore, the ratio is positive. Clear? I hope everyone understand, right? So, therefore, the graph is, we can say that f is increasing which interval? Minus infinity to minus 1 union 1 to infinity. So, f is decreasing in the minus 1 to 0 union 0 to 1. Clear? Because your x is equal to 0 is not defined, right? So, you cannot take this one. This is decreasing functions, right? So, therefore, which interval this function is, you can see which interval, what is the minimum value of this function you can see. So, x plus 1 by x is there, no? This is divided by 2 is greater than x into 1 by x. You can use the arithmetic mean and geometric mean. You can say x plus 1 by x. This is your f of x, right? So, this is greater than 1. 1 into 2. It is greater than or equal to 2. The minimum value of the function is more than 2. Okay. So, that means what we can say here. So, we can't say directly, you can say the minimum value of the function is what? More than 2. Whatever value you can take from this, the output value is more than 2 is only possible, right? The graph will be, it's more than 2. Okay. So, the function is what? Increasing in this order, minus infinity to minus 1, 1 to infinity is increasing, and decreasing in the minus 1 to 0, 0 to 1, right? In this interval is decreasing, right? Okay. I hope everyone understand, right? The image of the graph is what? More than 2. Okay. I hope everyone understand, right? Okay. So definitely this function is completely not one functions in the whole real number. But if you restrict the domain, it will be increasing or decreasing. I hope everyone clear, right? Okay, fine. Next graph. Next we'll discuss the next we'll discuss the onto functions. Okay, onto functions. What is onto functions? Suppose if you consider the function from a to b, okay, f is onto means if onto, if, so onto means what is the condition is required? Let y belongs to b. Take any element in the codomain. Then there exists, the symbol is there exists. There exists means we can find out. There exists x in the domain such that we can say, what is that? F of x equal to that y. This is your onto definitions. Clear? Onto is what? If you pick any element in the codomain, then I can able to find a corresponding one element in the domain. That image would be that y. That means what? Every element in the codomain has a pre-image. If you pick, what is mean by onto function? The function from a to b is onto. If you take any element randomly, you can choose one element in b. Then I can find the element in a, that is x. That image of that x will be y. Clear? That means here you can see this is not onto functions. Not onto. Why it is not onto? This element b3 does not have the pre-image. Understand? Let me take one example. Suppose if I consider f of x equal to x square. Let's take the function from real number to real number. Okay. Let's take x square plus 1 you take. Okay. You can see the graphically x square graph is this one. Y is equal to x square. But x square plus 1 means what? You have to shift 1 unit up, right? 1 unit shift up. This is y is equal to x square plus 1. This graph, what is the range? The range means you can see you have to focus on the y-axis. The y value, this is what? 0, 1. 1 to infinity is the range. What is the range? Range is equal to 1 to infinity. But here is the codomain is the real number is given. So definitely it is not onto. Why? Because every element in the codomain has the pre-image. But here the range is 1 to infinity. If I take here 0, if I take y is suppose 0, right? But x square is equal to what? Plus 1. How to find x here? X square is equal to minus 1 is not possible, right? You cannot find all the elements in the domain, codomain has a pre-image. Therefore, it is not onto. It is simply in other way we can say range is equal to codomain. Range is equal to codomain. This is your onto functions definition. How to use the definition? This definition how to apply here? Let me take one element. Let us take one element from the codomain. Let's take L. So let us take y here. Y belongs to where we can take it, where we can take real number. There exists x belongs to R such that f of x equal to y. What is f of x here? You can say x square plus 1, right? Is equal to y. Find out x here. X square is equal to what? Y minus 1. Correct? So x is equal to what? Plus or minus square root of y minus 1. Correct? This is your x value, suitable x value here. But when it is possible, when it is defined under the square root, when the y minus 1 should be greater than 0 only possible. So y minus 1 should be greater than 0. That means y is greater than 1 only possible. The x value we can find out when y is greater than 1. Then only x values find out from the real number. Otherwise, it's a complex number. There is no such x value possible for any real number, any number from the codomain, right? We cannot corresponding y, we cannot all the possibilities, we cannot get it. When it is possible, when y is greater than 1 only possible, then only you can find the x is the real number. Understand? Otherwise, it's a complex number case. Under the square root is negative number, mean it is belongs to completely complex number. Clear? Okay. Fine. I hope everyone understand this one, right? Okay, let me take another example. Suppose if I take the function from real number to real number, f of x, you can take x square. Let's take this one. Let's take x square minus, let us take minus 2 plus 1 or 3 plus 1 you can take, no, minus 4x plus 3 you can take, right? If I take this function, this is onto functions or not, how to check it here quickly. First you can find out the range of this function. What is the range of this? You can see, student, x square minus 4x plus 3 is there. Now make it to perfect square first. Easy way is make it to perfect square, right? Otherwise you can draw the graph also, it's anything is fine. You can see if I coefficient of x is there, no, what is 4? You divide by 2, x minus 2 whole square, expand it. What will get? X square plus 2 square is 4 minus 4x. X minus 2 whole square minus 4 equal to x square minus 4x. We need plus 3, so you can add plus 3 on both sides. X minus 2 whole square minus 4 plus 3 is equal to x square minus 4x plus 3. Clear? So now you can see x minus 2 whole square minus 1 is equal to x square minus 4x plus 3. This is equivalent definition. Equivalently, we can write x square minus 4x. You can simplify this x square plus 4. 4 minus 1, it is 3. So 2 into 2 is of minus 4x. Yes, is there, right? Okay. Now you can see, student, x minus 2 whole square is always greater than 0, right? Because the positive is square is perfect square, no, it is greater than or equal to 0. It cannot be negative. You can add minus 1 on both sides is greater than minus 1. Clear? It's greater than minus 1, right? Adding minus 1 on both sides. This is equal to what? X square minus 4x plus 3 is greater than, right? This is your f of x, right? F of x, it's greater than minus 1. It's greater than minus 1. So this is y. So y should be greater than or equal to minus 1. Therefore, y belongs to minus 1 to infinity. This is your range. But when you draw the graph of this, you can see, student, y is equal to x minus 2 whole square minus 1. You can see this is your x-axis, y-axis, x minus 2 whole square graph. You know what you can do? The reference graph is x square. You have to shift 2 units right. Right 2 comma 0 here. This is 0 comma 2. 2 units shift right. Okay. And you have to shift 1 unit down, right? Minus 1 is there, no? 1 units down. So this is your 2 comma minus 1, correct? This point is what? You can see this is 3 comma 0, this is 1 comma 0. X-intercept is 1 comma 0, 3 comma 0. Then you can see the minimum possibility is what here? So 2 comma minus 1, minus 1 is the minimum. So the graph range is what? The range of the graph is, you can see it will not below minus 1 is not there. The range is, you can say that minus 1 to infinity. Therefore, this function is not onto. Why? Because you can see the function from real number to real number is given. It is not equal to codomain. Codomain is here is what? R. Therefore, the f is not onto. Clear? I hope everyone understand. So we'll discuss more problem later. Then after that, we'll discuss the number of functions. How to find the number of functions? Let's see. Let me take this case. Okay. Before that, we'll discuss the few questions, and you can see when you take another page. Okay, you can see, let me take another page. Number of function, how to find the total number of function, total number of functions, how to find it. Suppose the A function from A to B you can take. Suppose n of A you considered n of B you consider m. Okay, number of elements in the domain is n and the number of elements in the codomain is m. How to find out? Let's take here. This is A, A1, A2, A3 up to An. Let's take B. This is B1, B2 up to so on Bm. Okay. So how to find the number of functions, students, quickly? It's very simple. You can see A1, how many possibilities there? You can see m possibilities there here. Either B1, B2, B3, Bm. Any possibilities there, right? This input has any one of the m possibilities, right? You can associate, right? There is no restrictions, right? The function means what? Every element in the domain has the output. At the same time, all the input has the output. That means you have to check each of the number from the domain. You have to check A1 to An. So A1 has m choices there. A2 m choices there, right? A2 also already mapped also it will map, right? For example, if I take A1 here and the A2 also B1 will get, understand? So this is also possible, right? Okay. Therefore, the A2 has m choices up to An has m choices. Therefore, the total number of functions is what? Number of functions equal to, how to say this one? The total number of functions equal to m into m into m into, how many times you are multiplying? N times you are multiplying. Therefore, m times n. 2 into 2 into 2. What is that? 2 power 3 you can write. Now, the same idea. M into m into m. n times you are multiplying m power n. Simply the number of functions, you can say the cardinality of the codomain. So cardinality means n of codomain rising number of elements in the domain. This is your idea. I hope everyone understand the number of functions. Because there is no restriction is there, A1 has the m possibilities and A2 also m possibilities there. Understand? We already discussed this. A2 map to B1, A1 also map to B1. So there are m possibly any one of the number can map. Understand? Okay. Next, we'll discuss the number of one functions. Number of one functions, one-to-one functions. Okay. Let us take two. You can see the function from A to B, you have to define. Suppose n of A here is n you take, n of B you can take m. Okay. Suppose if I take A here is 3 elements and B here is 4 elements, right? This case one function is possible or not. Suppose n of A is less than n of B. Let us take here A1, A2, A3. Here is B, this is A, B1, B2, B3, B4. Yes, possible, right? You can see, you can map like this. Is a function as well as one function. What is a one function definition? Distinct element has distinct images, right? Okay. Therefore, one function is possible. You can see how to understand this one functions. You can see A1 is mapped to 4 possibilities there. So A1 has what is the possibilities? A1 having 4 choices there, right? Either map to B1, B2, B3, B4. Now A1 map to B1. Any one only is possible, right? The 4 choices for the A1. So A2, what is the possibilities? If suppose A1 is mapped to B1, is the one is fixed. Then A2, how many choices there? 3 choices there, right? 3. Then A3, 2 choices there, right? Correct? Understand? Therefore, the number of one functions, how to determine this one? Number of one functions will be 4 into 3 into 2. How much it will be? 12. 12 into 2 is 24. 24 function is possible. Clear? Number of one functions. How to generalize this one? Another way how to write in a permutation way. First we have to write the permutations way, then we can write it in generalize, right? Okay. So you can see there are 4 elements here. Here is 3 elements. So 4p3. 4 element is there in the codomain. You pick 3 elements and arrange it. Why? Because the domain have 3 elements only is there, right? So 4p3 means what? 4 factorial divided by 4 minus 3 factorial. This is 4 factorial divided by 4 minus 3 factorial is what? 1 factorial. It is 4 into 3 into 2 into 1. That is 12. 12 into 2 is what? 24. Right? This is another way we can represent this one. Because you are picking the elements and you are arranging it. Right? Okay. So how to generalize this? If n of A is less than n of b, that means n is less than m, the number of 1 functions is equal to m p n. It is same as m factorial divided by m minus n factorial. Understand? It's another way also we can say here. But NCR formula you know, right? N factorial divided by R factorial into n minus R factorial. So, m factorial by m minus n factorial is there, no? So, how do you write this one? This is your NPR. How to write? You can see this is NPR. How to write? R factorial into NCR we can write. Clear? Okay. Then how to write MPN? That form how to write in terms of combinations? MPN is equivalently how to write? You can see R factorial means here is n factorial, right? Correct? N factorial into NCR means here you have to take MCN, right? So MCN. Clear? R here is N, M here is N. So, understand? R here is N, M here is N. I hope everyone understand. The number of 1 functions how to write? MPN, N factorial into MCN. Clear? Okay. Suppose n of A is greater than n of B. That means what? You can consider n is greater than m. Consider this case. What is the possibilities there? You tell me, anyone, student? If I consider, let us take n is equal to 4 and m is equal to 3, you can take. So, let us take this is A, this is your B. 1, 2, 3, 4. Let us take A, B, C, you can take. So, in this case, you can see 1 goes to A, 2 goes to B, 3 goes to C. But distinct element has distinct images, right? Then only one possible, right? But here is domain is more than the codomain. So, definitely 4 does not have the image. So, therefore, it is not 1 The number of 1 functions equal to 0. We cannot find the number of 1 functions because 4 does not have the, first of all, it's not a functions, right? Because the 4 does not have the image. Understand? Then only we can talk about the 1 functions, right? Okay. Suppose the next case, suppose m is equal to n. M is equal to n. This is your case 2 you can take. This is you can take case 1 you can take. This is your case 1. Okay, understand? This is case 2, this is case 3 you can take. Let's take 1, 2, 3. A is equal to 3 and B also 3 only, right? Let's take A, B, C you can take. Okay, 1 goes to A, 2 goes to B, 3 goes to C. Distinct element has the distinct images. So, definitely we can say that 1 has how many choices there? 3 choices there. So, 2, how many choices? Suppose 1 is mapped to A. Then 2, how many choices there? 2 choices there. And 3, sorry, 2 having 2 choices there, right? 3 having 1 choices there. Therefore, 3 into 2 into 1 possibilities, it is same as 3p3. 3p3, right? Because you can see this is 3 factorial by 3 minus 3 factorial. This is 3 factorial by 0 factorial. It is same as 3 factorial. 0 factorial defined as 1. Clear? Okay, therefore, we can say that it is 3 factorial possibilities there. How to generalize this? If m is equal to n, here is same as 6 here, right? Total number of 1 functions in this case is 3 factorial, same as 6 function is possible. If both are same, domain and codomains are same, we can find out number of 1 function is what here in this case 6. In general, how to write? In general, number of 1 functions here is n factorial or m factorial also we can say, or m factorial, because both m and n are same here. Clear? I hope everyone understand. Okay, let's go for the onto functions. Number of onto functions. Number of onto functions. This is somewhat tricky. Onto functions means what? If you take the domain and codomain, every codomain element has the pre-image. That means the range is equal to codomain, right? That is the onto functions, right? Number of onto functions, how to calculate here? Before that, you have to understand the inclusive exclusive principle. Inclusive and exclusive principle. Exclusive principle, right? Okay. If you take this one, suppose if I have the set like this, A, this is B. Okay. So n of A union B, how to write? N of A, first you can cover complete A, in that intersection included. This is your intersection, right? This is your intersection. Intersection 1 times included. N of A, if you take no complete intersection you take. Then n of B. When you take n of B, there also included, 2 times included, right? So you have to take 1 time because the intersections 1 time only is there, right? So you have to remove the 1 times intersection. Clear? Then only you can take the union. What is the meaning? At least 1 of A. At least 1 of A or B. At least 1 of A, B. That is A union B. Whenever the word using at least, you have to take A union B. This is called inclusion, inclusive. This is exclusive. Subtracting means exclusive. In adding means inclusive. Exclusive. The same way, you can take n of A union B union C, you can take. So, how to do this? You can take the Venn diagram. This is A, this is B, this is your C here. Okay. So, when you take n of A union B union C, that means at least 1 of A, B and C. First, you collect n of A, n of B. So, when you take n of A, you can see when you take n of A intersection B you are taking, right? And then A, what is this portions? You can see this portions will be what? A intersection B intersection C. Okay. So n of B you added, again you're adding, right? Again you added, right? So when you take n of B, A intersection B is there, right? N of C you can take, n of C. First you take n of A completely. In that, which are the things you added here? A intersection B and A intersection C is there, right? So we have to remove 2 times added here. When you take A, A intersection B added. When you take B, A intersection B added. So we need to remove one time n of A intersection B. The same way you have to remove the n of B intersection C, n of C intersection A. Clear? But when you take this case, A intersection B intersection C is there, no. When you take A, right, when you take A, listen here, when you take A intersection B added. When you take B, A intersection B added. So you have to remove one time. But when you take A intersection B, you removed one time, here one time added, two times added, one times you removed. But here you can see n of A intersection B intersection C, if added and here you are removed, added, removed. So that portion is not included in the union. So you have to add one time. Okay. So n of A intersection B intersection C. Clear? This is your at least one of A, B and C. I hope everyone understand this one, right? So adding is the inclusion, subtracting is the exclusion, again you're adding inclusions, right? Okay. So when you take the number of onto functions, you can see the function from A to B you can take, n of A you can take n of B you take m here. Okay, let me take, this is A, this is B. Clear? Let's take A1, A2, A3, so on, AN. Clear? Here B1, B2, B3 up to BM you take. Clear? So we need to find the number of onto functions. Number of onto functions means what? First you find all the total function. We already know the total, how to find the total number of functions. Remove the which is not onto functions. That is the logic here. Number of onto function, how to find out? Total functions minus number of not onto. Not onto. This means into functions. Right? Into functions. Clear? Total function minus number of not onto functions. You have to remove it. Not onto means what? Onto means what? Every codomain element has the pre-image. Not onto means what? At least one of the elements does not have the pre-image. Understand? That's the logic here. First, for that, first let us calculate. Let us calculate number of into functions. Into functions means what? Not onto functions. Not onto functions. Not onto functions means what? At least one of BIs does not have pre-image. Okay. Let me take one simple example here. Let us take here the let me take here is I'm taking that n of A is we'll discuss that case. First we'll understand how to find the number of into functions, right? Suppose n of A you consider 3, okay. So n of B you can take 2. In that case only onto functions is possible and equal to case also possible, right? Let's take here. So A1, A2, A3 you can take. Here B1, B2 you can take. Clear? Okay, this is A, this is B. 3 element is here 2 elements. You can say that is onto function is possible or not. Possible. When the codomain is more than the domain, if suppose if it is there, here is 1, 2, 3, here is A, B, C, D is there. If I take here, D does not have the pre-image. So that case, so onto does not exist. If codomain is more than the domain, the onto functions is not possible here. So that's why I'm taking the domain is more than the codomain case. That case, how to find the number of onto functions? Suppose the first one number you take, 2 number is there. Suppose B1 does not, we have to find out how to find out the number of not onto functions. Not onto functions means what? Number of into functions. Into functions means what? At least one of the BI does not have the pre-image. Okay, suppose B1 does not have pre-image. Okay, then this does not have the pre-image means the domain, how many possibilities there you can see? A1, A2, A3. So A1, how many possibilities there? One possibility is there. A2 also one possibility is there. A3 also one possibility is there. Clear? Understand? Let me generalize this one. Let me take this is A1, A2, A3 up to AN, right? AN. This is B1, B2, B3, so on, BM you take. This is A, this is B. Okay, suppose B1 does not have pre-image, does not have pre-image. So that means what? This element does not have pre-image. Okay, so that means there is no mapping, right? So A1, how many possibilities there? M minus 1 possibilities there. A2 also M minus 1 possibilities there. A3, M1, M minus 1 possibilities. Any, if you pick any element in the domain has the image should be any one of the M minus 1 elements because B1 does not have the image, pre-image. So the same way AN also M minus 1 possibility is there. So therefore, so how to write it? Here M minus 1 whole power N possibilities there for first case, right? If B1 does not have suppose there are M element is there, you pick one element. MC1 you have to take. You take B, not only B1, any one of the BM, you take one element, right? Okay. So for that, what we can do here, at least one of BI does not have the pre-image. That means what? I am taking B1. So you can say here it's M minus 1 whole power N possibilities there here, right? You pick M element is there in that. So you have to choose one element here first. So that means at least one of the BI does not have the pre-image. What you can do, that at least means what? You have to take the union, right? You know that N of A union B union C. How to write? N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of C intersection A. Correct? And add the N of A intersection B intersection C. Clear? So we already discussed this. Okay, here how to find out this? N of A is required, no? Okay. So first what you can do? First you can select M element is there, no? You select one element. MC1. If one element is selected, you can see how many possibilities there. You can see each one have m minus 1 possibilities there, right? Each one. So m minus 1 whole power n possibilities there, right? Okay, clear? This is the first one. Then you can see minus at least one, no, inclusion and exclusions possibilities there. Two elements if you take. If you pick two elements, if two elements here, there is no pre-image means, what is the possibilities there? M minus 2 possible ways to arrange, right? Remaining n element is there, no? If two element does not have pre-image, let's take these two. Remaining m minus 2 elements is there. So each element A1 has m minus 2, A2 has m minus 2, therefore m minus 2 whole power n possibilities there. So plus MC3 m minus 2 m minus 3 whole power n minus so on. This is your the number of into functions, right? Number of into functions. Clear? Then how to find the number of onto functions? Number of onto functions. How to write? Total functions minus number of into functions. Okay. So first let me take another page. Total functions is what? Here n of A is what? N of B here is M. So total function is what? M power n, because the codomain, number of elements, the codomain power number of elements in the domain. We already discussed this. Minus, you had to remove this one, right? So MC1 m minus 1 whole power n minus MC2 m minus 2 whole power n plus MC3 m minus 3 whole power n minus so on, right? Clear? Now you can multiply inside here. What is that? M power n minus MC1 m minus 1 whole power n minus into minus plus MC2 m minus 2 whole power n minus MC3 m minus 3 whole power n, right? Plus so on, right? Okay, how to write this one? Summation r vary from 0 to m minus 1. You can see r vary from m minus 1. So MCR, you can see 1, 2, 3, it's varying, right? MCR you can write. Minus 1 to the power R, you can see here also varying, right? 1, 2, 3, it's varying. Let us take R. M minus R whole power, what is that? N. Clear? This is a generalized idea. Suppose if I take R equal to 0, suppose you can take here, so how will you get m power n? You can see some students will think about it. So if you R is equal to 0, you can take, what will get? MC0 minus 1 to the power 0 m minus 0 whole power n. So you can, how to write this one? MC0 is 1 minus 1 to the power 0 also 1 m power n. First term you will get it. Understand? Therefore, this generalized, the ideas will be like this. So minus 1 to the power r, why we are writing like this? Because it depends on the power. Suppose if you 1, if you take, minus is there. If I put 1, 2 here is there, second term will be, you can see. If I take 1, so you will get, you can see second, if you put here, so r equal to 0 means m power n will get. Let me take r is equal to 1. 1 if you put, you will get negative number. Second term will get. This is the formula for the number of onto functions. The many of the students is facing difficulty in this. Very simple. a number of onto functions, how to calculate? Total number of functions minus number of not onto functions. Not onto functions means what? Into functions. Into functions means what? The codomain elements is there, no? B1, B2, B3. At least one of the BI does not have the pre-image. If all the elements has pre-image means it's onto function. If at least one of BI is not pre-image, not having the pre-image means, so not one, that is into functions, right? That will discuss through the inclusive and exclusive principle. I hope everyone understand, right? Okay, let me take so one example. Let's take the onto function. Suppose case wise we'll discuss. Suppose the functions from a to b you can take. So n of a is equal to n of b is equal to m you take. Clear? The case 1 you can take. Case 1 is n of a, suppose less than n of b you can take. Suppose here is n of a, let us take 4 you can take. So n of b you can take, let us take 5. Okay. So here is 1, 2, 3, 4. Let's take A, B, C, D, E, F you take. So when you take this case, 1 goes to A, 2 goes to B, 3 goes to C, 4 goes to D. Suppose the possibilities you can see 4 and I have to remove this one. 5, right? 2, 4, 5. Yes. So in this case, he does not have the pre-image. That case is onto function is not defined. So the number of onto function this case, what is this case? If n of a is less than n of b, that case is will be 0. Number of onto function is what? If n of a, you can remove this one quickly. If n of a less than n of b means number of onto functions will be 0. Clear? Okay. Suppose if n of a is equal to n of b, case 2 you can take. N of b is equal to m. Suppose n of a is greater than n of b. So that means n is greater than m. This case is n is less than m. Here m is more than the n, onto function is not defined because so at least one of the elements here does not have the pre-image. Okay. So when you take this case, let's take n of a is equal to 3 and n of b is equal to 2 you can take. Okay. So that case, let's take 1, 2, 3. Let's take a, b you can take. So you can see directly you can map it. 1 goes to a, 2 goes to b, 3 goes to c also. This is the function. So onto functions also possibilities there, right? Okay, I'm just connecting some example. Okay, so how to find out this case is number of onto functions. You can see what is the formula? We discussed that the first you find the number of onto functions. For that total functions minus number of into functions. Clear? Or you can use the formula or vary from 0 to m minus 1 mcr minus 1 to the power r. What is that? M minus r whole power n. But in this case, what is m? M, this is your n is 3, m is 2 here. So m is 2, n is what? 3. So just substituted here. I will take another page. So you can see I will write here. Summation r equal to 0 to m minus 1 mcr minus 1 to the power r m minus r whole power n. But m here is 2, n is what? 3. You can see here, n is 3, no? Yes. If you take this case, so then what will get? So suppose r is equal to 0 to, what is n? M here is what? 2 minus 1, right? Okay. So you have to take from m minus 1 is what? 1 only have to take. So MCR, what is M? 2C, what is R here? You take this one, R here. So minus 1 to the power R. M is what? 2 minus R. N here is what? 3. Just apply R0. 2C0 minus 1 to the power R is what? 0. 2 minus R here is what? 0 whole power 3. Clear? Plus the summation means addition. Okay, 1 you can substitute. 2C1 minus 1 to the whole power 1. So 2 minus 1 whole power 3. Okay. So that case 2C0 minus 1 to the power 0 is there, no? So this is 1. So 2C0 is 1, right? Minus 1 to the power 0 also 1, right? 2 cube is what? 8 plus 2C1 is 2 minus 1 to the power 1 is what? Minus 1, and 2 minus 1 it will be 1, right? Correct? 1 cube is 1 only. So therefore 8 minus 2 it is will be 6. Correct? 6 onto function is possible. I hope everyone understands this, right? Okay. So number of 1 functions, onto functions, all the cases discussed. One more thing is there here. Case 3, what is that? M is equal to n. N of A is equal to n of B. That case, number of onto function is what? Is n factorial only. Correct? Why it is n factorial? You can see if I take 1, 2, 3, here A, B, C you can take, right? So number of onto functions. So definitely it's how many elements, both are same. So n factorial, you can use that formula. Number of into functions, what is the possibilities there here? So any possibilities there, number of into functions? So all the element has the pre-image, no? So definitely it is, so number of into function is 0. Okay? Right? So therefore the number of onto functions is what? N factorial possibilities there, right? Okay? So this case the total number of function is n power n or m power m, you can say, right? Okay, fine. The bijective functions, bijective means what? Both 1, 1 and onto, or you can say another way, injective and surjective. Injective means 1, 1 function also we can say, and the surjective means onto functions. Another name is that way. Okay. Bijective means what? Both 1, 1 and onto. You can see, let us discuss this case. The number of bijective functions, this case is what? N factorial only. Both 1, 1 and onto is required. Okay. If one of them is not hold, some cases 1, 1 is there, not onto is not there. That case number of bijective is 0. Both 1, 1 and onto will be there, this case only, right? M is equal to n. The number of bijections also n factorial ways only. Number of bijections is what? n factorials. So bijection means what? Both 1 1 and on 2. I hope everyone understand this, right? Let me take quickly the questions. We'll finish this quickly. Let me take this first question. You can see. Where is that one? This one. Yes, the functions from real number 2, closed interval minus 1 by 2 to 1 by 2. This is the f of x equal to x by 1 plus x square. You can see this function is injective, surjective or invertible. Which one is possible here? Okay. Injective means 1 1 functions, surjective means onto functions. Let me check the 1 1. First, you can differentiate this function f dash of x equal to 1 plus x square whole square. Otherwise, you can check in other way also. Let me check this way. So 1 plus x square, you can keep it as it is, x differentiation 1, minus x, you can keep it as it is, then 1 plus x square differentiation 2x. Clear? X, you keep it as it is? Yes, correct. So you can simplify this 1 plus x square minus 2x square. Minus 2x square, right? Divided by 1 plus x square whole square. So this is f dash of x, right? So you can equate to 0. What you'll get, you can find the critical point because denominator is always greater than 0. So 1 minus x square equal to 0. So 1 is equal to x squared. That means x equal to plus or minus 1. You can see, student, when you take minus 1 and 1 is a critical point. You can check here. You can see, let me take, so if you take less than minus 1, let's take minus 2 you take. So what is that? F dash of x? F dash of x is 1 minus x square by 1 plus x square whole square. So denominator definitely is greater than 0. There is no problem. You have to check the numerator. Let's take minus 2 you can put here. 1 minus minus 2 whole square is 4. It's negative. Correct? Minus 2 whole square is what? 4. 1 minus 4 is what? Minus 3. It's minus 3 by positive. Its ratio is negative. Therefore, negative. Minus 1 to 0. Let us take 0 here. Put 0. 1 divided by 1. Clear? 1 divided by 1 is the positive. When you take more than 1, let's take 2. Again, you can see 2, 3, 4, whatever value you take, right? Let's take 3. 3 square is 9, 1 minus minus 8. Its ratio is negative again. Okay? So you can see the complete, we have to check on the functions on the real number domain, right? So the whole real number, the sign changes, you can see the f dash of x is less than minus 1 is negative, more than 1 also negative. That means if x belongs to minus, let me take another way, minus infinity to minus 1, union 1 to infinity. In this interval, the function is decreasing because f dash of x is negative. When you take x belongs to minus 1 to 1 in this interval, so the function is increasing, positive. Therefore, the whole interval, the real number, the function is positive, that changes f dash of x is both positive and negative is there. Therefore, this function is not injective, right? Not injective. And otherwise, you can take here f of x, you can fix 1 by 4, you can solve this, you can find the two different x value, right? Two different x value you'll get, two distinct solution you'll get, right? So if two distinct solutions, one image means two different value, but the same image means it is not 1 1 functions. Okay? If you put f of x, you can y is equal to 1 by 4 you take, and you can solve it, you can find x value, this distinct solution is possible. That way also you can find out. So we can say this function is not injective, we can say. Okay, so what about that surjective? So you can see surjective, how to check it. F of x equal to what is that? So very quickly we can do it. Okay, you can see what is the surjective. Let me take this page. Where is that page? Here, right? Yes. So we need actually, yes. Okay. Surjective means what? Onto functions. How to check it? You have to find the range of this function. F of x equal to x square divided by, sorry, x divided by 1 plus x square. X divided by 1 plus x square. We check it once again. Is it correct or not? Yes. So let us take this as y. So you cross multiply, find the range of this x, right? So y plus x square y minus x is equal to 0. Clear? So you can see in this case, you take y out. Y, if you take, no problem. You write in the quadratic equations form, x square y minus x plus y is equal to 0. You can see this is quadratic equations. We need real solutions. What is a? Take y. What is b? Minus 1. C is y. So b square minus 4ac is greater than 0. It's real solutions means for real solutions. Okay. What is b here? Minus 1 whole square minus 4 into a is y. C is what? Y here, right? Greater than 0. 1 minus 4y square is greater than 0. Clear? So 1 minus 4y square, whenever this kind of things you have to write y minus something, you take minus common. So 4y square minus 1 square is less than, sorry, it's greater than or equal to 0. Right? You can multiply now minus 1. What will get? 4y square minus 1 square is less than or equal to 0. Right? You can multiply by minus 1. This is how to write 2y whole square minus 1 square less than 0. This is 2y plus 1 into 2y minus 1 is less than 0. You can draw the number line. You can see here, student. So what we can take? Minus 1 by 2 plus 1 by 2. You can use the wavy curve method. If you're not having any idea, you can watch my one shot wavy curve method idea, right? Start with a positive. 1 by 2 is odd power, change the sign. Minus 1 by 2 also odd power, change the sign. Negative, positive. So therefore we need y is belongs to minus 1 by 2 to plus 1 by 2. So range is equal to codomain. Therefore here it's same as range is given. So this is range. Here is range is equal to codomain. Therefore f is on 2. Okay, therefore which option is correct? You can see neither injective nor surjective. This is not possible. This is not correct. Invertible means both 1 1 and on 2. This is also not correct. Injective but not surjective. Injective is not possible because this function is completely increasing and decreasing in the entire domain. So it's not possible. Right? Surjective but not injective. This is only correct. Okay. Let's go to the next question. This is f of x equal to modulus of 1 minus 1 by x is given to you, right? So f of x equal, you can draw the figure, you can easily find out 1 minus 1 by x, right? you can, first you draw the 1 minus 1 by x graph, right? Before that, you can see how to draw this graph. First, you can draw the 1 by x graph and then minus 1 by x graph and then minus 1 by x plus 1 graph. So, you can see 1 by x graph is there. Now, why you take 1 by x? Cross multiply xy is equal to 1. The product of the two numbers equal to 1 means it will be lies in the first quadrant, both are positive you can take, or third quadrant, both are negative you can take. This is only y is equal to 1 by x. Clear? So, why we are taking it as why it is not crossing the x-axis? Because it will not be 0. If put x is equal to 0, what will happen? So, 1 by 0 it goes to infinity. When x is closest to 0, it goes to infinity, right? This is a 1 by x graph, right? Okay, minus 1 by x means what? So, you take the x-axis the image, right? So, whenever the f of x changes to minus f of x means you take the y-axis the image, x-axis the image, sorry, x-axis the image, this graph, right? Okay, so the same way here, this portion you take the image, the graph will be like this, sorry. So, how this graph will be like this will come. This is your graph of minus 1 by x, right? You shift 1 unit up, but you can see the x values are from 0 to infinity. No need to think about the negative side. So, you have to think about only the positive side. So, positive side you can see you have to shift 1 unit up. This is 1 if you take, if you put 1 here, what will get? 0. If you substitute in the graph, 1 will be 0, right? So, you just use shifter, right? 1 units up, right? Okay, if I take minus 1 by x, if you put x is equal to 1, so where this graph is a minus 1, this graph, right? Okay, that's correct. If you add 1 here, minus 1 if you put, it will be 0. So, it will be going like this. It will be going like this, right? Right? Okay, sorry, it will be somewhat different. Okay, it will come like this. But when you take the modulus here, when you take the modulus, this negative part will be removed, right? So, this will be going like this, right? This is your graph. But when you take 1, if you put 1 here, it's 0 only, no? Yes, correct only, the graph. So, the entire graph is how to draw the graph? This graph will be, if you put 1 here, 1 minus 1 is 0. It will be going like this. This will be going like this. This is the graph. Okay. So, when you draw this graph, so you can see draw the horizontal line. You can see if you draw a horizontal line, it will crosses more than one point. Therefore, it's not at all one functions. Understand? You can draw here. So, more than one point it's crossing. Therefore, it is not one functions, right? So, okay. So, what about the onto functions? So, onto will work, right? When x equal to 1, it will be 0, right? When x is more than 0, it is goes to infinity, right? You can see the graph. When x is closest to 0, 0 plus, approaches 0 plus, you can see limit x goes to 0 plus, then mod 1 minus 1 by x approaches to is infinity, right? Positive infinity. So, when you take f of 1, you take 0. So, all the range it included, right? So, 0 to infinity. The function is onto functions, but the function is not injective. Why it is not injective? Because it crosses more than one point. That means some interval the function is decreasing, some interval the function is increasing. So therefore, the whole interval the function is increasing and decreasing means not 1. The whole interval either completely decreasing or completely increasing. That way only we can say it is a 1 function. Definitely it is not 1, right? So therefore injective only is, this is not correct. Not injective, correct, but it's surjective. Second option is correct. Both injective as well as surjective, not at all correct. Neither injective nor surjective. No, because it's onto. Why it is onto function? Why it is onto functions? When you substitute x equal to 1, it will be 0. When x is approaches to positive, it goes to infinity, positive infinity. 0 to infinity is the range. Clear? Okay, we'll go for the next question. Let's take this question. So what you can do here, let's take this 1 and onto. For that you have to differentiate this function, right? F dash of x you can calculate. Just u by v quotient rule you can use, x square plus 1 whole square. You can see, student. So x square plus 1 you can take as it is and differentiate the numerator. So 2x plus 2, right? One differentiation is 0 minus x square plus 2x plus 1 you can keep as it is, and x square plus 1 differentiation is what? 2x, right? Now you can multiply inside 2x cube plus, you can say 2x cube plus 2x square plus 2x plus 2 minus x square, sorry, minus 2x cube, right? Minus 2x cube. Here also minus 2x cube. You can see minus 2x cube, then minus 2x square minus 2x, right? Whole divided by x square plus 1 whole square. Okay. Now 2x cube minus 2x cube cancel, 2x square minus 2x cancel, and what is left actually? We did correct or not? X square keep plus 1 you can keep as it is, 2x plus 2 correct. This you can keep it as it is correct. 2x cube plus 2x square, 2x plus 2 correct, minus 2x cube minus 2 into 2 is 4x, right? We did one mistake here. You can see we had to remove this one. When you multiply minus 2x cube, correct, minus 2 into 2 minus 4x square, right? You can see. So remove this one. Okay. So here is 2x square is fine. So no issue. 2x square, 2x cube plus, yes, correct. So when you multiply minus 2x cube is correct. When you multiply 2 into 2 is of minus 4x cube is only correct. Minus 4x square. Minus 2 into 2, 4x square minus 2x. That is correct. Okay, now this will be cancelled. 2x square minus 4x square is what? Minus 2x square. Okay, so then plus 2x and minus 2x also cancel, right? Plus 2x minus 2x cancel, and plus 2 will be left, divided by x square plus 1 whole square. I hope everyone understand, right? We'll go for the next step. So what is that? F dash of x, check it once, minus 2x square plus 2, right? Minus 2x square, f dash of x equal to minus 2x square plus 2 whole divided by, what is there? X square plus 1 whole square, right? X square plus 1 whole square. Equate to 0. What will get? Minus 2x square plus 2 equal to 0, because Denominator anyway greater than or equal to 0. So minus 2x square is equal to minus 2, minus cancel, then x square is equal to 1, right? 2, 2 also cancel, right? So x is equal to plus or minus 1. You draw the number line, you can see minus 1 and plus 1. If less than minus 2, you check here. Let's take minus 2. Minus 2 into minus 2 square is 4, plus 2, it is minus 8, plus 2 is minus 6 here, right? Sorry, minus 8 plus 2 is minus 6 only, right? It's negative. The ratio is negative because the denominator anyway positive. The ratio is numerator is negative, denominator is positive, ratio is negative. Minus 1 to 0 you can take. Let us take 0. 0 if you put here, 2, 1, it's positive. When you take more than 1, let's take 2, you can substitute. 2 you can substitute, definitely you can see when you take 2, it will be 4, it's again it's negative. Okay, correct? Yes. So therefore x belongs to minus infinity to minus 1 union 1 to infinity. The function is what? Is increasing, sorry, decreasing, because negative sign, no, f dash of x is negative, it's decreasing, and x belongs to minus 1 to 1, it is increasing. So therefore which option is correct? The fe is 1 to 1 in minus infinity to minus 1. Many one or not. Many one means what? Not 1 functions. Many one means what? Not 1 functions. Minus infinity to minus 1. It's many one or not. Minus infinity to minus 1, it is completely decreasing. Decreasing means if you draw horizontal line, it crosses at most 1 point. 1 function. So here is given to you, it's not correct. Many one function is given, not correct. fe is 1 in the entire real number, it's not at all correct. Why? Because you can see it will be divide this into whole real number, less than minus 1 it is negative, more than 1 also negative, between is positive. The sign changes there. In the whole interval, there is no sign change, either positive or negative. Then only it is 1 function. Because here is the sign changes there, therefore this is 1, it is not true. So many one in 1 to infinity, that is also not correct. Why? Because 1 to infinity, here you can see 1 to infinity, why it is not true? So 1 to infinity is decreasing, it's 1 functions. Okay, therefore this is not true. 1 in 1 to infinity, but not in minus infinity to infinity. Why this is true or not? 1 to 1 in 1 to infinity is correct or not? 1 to infinity is definitely decreasing, therefore 1 functions, but not in minus infinity to infinity. Yes, correct. So therefore fourth option is correct. Clear? Okay. We'll go for another one. You can see this question we can take. You can see this. X be the set with exactly 5 elements and y be the set with exactly 7 elements. Alpha is the number of 1 functions from x to y. Beta is the number of onto functions from y to x. So we need to find the beta and alpha, right? So first alpha is what? Number of 1 functions. First you have to write what is a, what is x, right? This is your x, this is your y. Clear? Okay. So what is x here? Set x has 5 elements. Let's take a1, a2, a3, a4, a5. And y has 7 elements. b1, b2, b3, b4, b5, b6, b7 you take. 7 elements. Now you need to calculate the number of 1 functions, right? You can see already we discussed that if 1 functions, when it is not defined, when it is 0, if code number of elements in the domain is more than the codomain. But in this case, the domain is less only. So we can form the 1 1 functions. We already discussed that A1 has the 7 choices there, right? A1 has 7 choices. A2 has 6 choices, right? One of the elements is fixed for element in the y. So we have 6 choices for A2. A3 is 5. A4 is 4. A5 is what? 3 elements. Therefore, the number of 1 1 functions how to write? It is 7 into 6 into 5 into 4 into 3. This is same as what? 7p, what is the 5? 7p5. If you simplify this, you'll get the same thing, right? Okay. Next, this is actually alpha. So beta, you have to calculate the number of onto functions from y to x. Let's take this another page. Let me take another page here. So number of onto functions, right, from y to x. So y, how many elements? B1, B2, B3, B4, B5, B6, B7. And here you can see the x has how many elements here? X is 5 elements, right? A1, A2, A3, A4, A5. Clear or not? You can see the number of, yes, you can see student finally. Yes. You can check here quickly. This is 5 elements. Yes, correct. 5 elements is 7 elements. We need to calculate 1 by 5 factorial into beta minus alpha, right? Okay, fine. So how to find out? I will teach you another way. We already discussed the formula to find out the number of onto functions. I'll teach you another way using the permutations, right? Suppose you consider the 7 books. These are the 5 boys. You have to distribute 7 books into the 5 boys. How many ways to distribute this? So you can see 7 books. You can distribute one, at least you have to remember this one, at least one of the elements, so any element in the codomain has the pre-image, right? That's the logic for the onto functions, right? But what is my question? I'm just changing into permutations way, same only. So that means every elements in the codomains has the pre-image. That means what? At least one of them, at least one person have the one book, at least one book having 1%, right? So that means how to write this? 7 books distribute among 5% can get at least one book, each person's, right? At least one means one or more than one. So one you can keep here, one, here is 1. Let's take here is 4, here is 3, right? This is one possibility is there. Or 7 books you can take 1 1 1 1 1. You can take 2 2, right? This is only possibilities, right? You already know that division into group, how to divide the group. 7 books is there, so you are distributing among the 5 persons. How to distribute? So you have to put 1 1 for first 4%, and then you last person you can give 3. Otherwise, you can give 1 1% first 3 persons, and then you can third person you can give the 2, and the fourth is fourth person you can give 2, and fifth person you can give 2. This is the possibilities. You already know that how to divide the division into group. You know how to do this? You know this? The 7 factorial divided by. So, how many thing is repeated? You have to take it. That's the logic is, there are 7. You have to choose one first. Remaining how many is there? 6 is there. You have to again choose one. Remaining how many is there? 5 is there. You choose again one. Remaining 4 is there. You again choose one. Then you automatically form the third final group. So what is the meaning? Your 7 things is there. You divide into 5 set of groups. Each group contains at least one. Understood? So this is 7 factorial by 1 factorial, 1 factorial, 1 factorial, 1 factorial into 3 factorial. Okay. So understand? So but here is the 4 1 is repeating here. 4 1 is repeating. So what is the possibilities there you can see? So 4 factorial you can divide it. You already know that if the number of letters are repeating, you have to divide it that one, right? If you're not having idea, I will teach you in the permutation combination one shot video, right? Okay. So 4 factorial, okay. But you are distributing among the 5 person, no? Multiply by 5 factorial. 4 1 3 factorial, and this 4 factorial is why we are doing this. 4 terms are identical here, right? Or means addition. 7 factorial divided by 1 factorial, 1 factorial, 1 factorial, and this last one you can see, this is 1 factorial, this is 2 factorial, 2 factorial. You can see 3 1 is there. For that you have to divide by 3 factorial, okay, and 2 2 is repeating, so for that you have to divide by 1 by 2 factorial, okay, and you're distributing among the 5 person into 5 factorial. Clear? This is the number of way to find the number of onto functions, okay. Just 7 books you distributing. Just I'm considering y as the books and x is the persons, 5 persons. You're distributing 7 books into the 5 person, at least can get 1 books each of them, right? This is the number of onto functions. In other way, read state this one, right? Okay. You can simplify this. What will get answer? So the 7 factorial is there, no? 7 factorial, how to write? 7 into 6 into, you can see 5 into 4 into 3 factorial. Otherwise, you can write 3 into, listen here. So 4 into 4 factorial you can write, divided by the 1 here, 3 factorial into 4 factorial. 4 factorial cancel. Okay, here is 6, no? 3 into 2, 6, 6, 6 cancel. Here is 75 you will get. 75, this complete, this one only 75, right? So multiply by 5 factorial. 5 factorial is 120, right? Correct? So 5 into 4 into 3 into 2 into 1. 20, yes, 120. You check it once. 7 is correct. 4 factorial, yes, we can write 4 factorial to cancel. Yes, correct. Plus, here how to write 7 into 6 into 5 into 4 into 3 factorial we can write, divided by 2 factorial into 2 factorial into 3 factorial into 2 factorial into 5 factorial. So what you can do, 3 factor cancel, this 2 into 2 it's 4, this 4 will be cancelled, and this is 1 times 2, so here is 3 times, then what will get 7 into 3 into 5, 7 to 3 into 5, correct, That's almost 7 into 3 into 5. Yes. So into 5 factorial. So here how much? Remove this one. You can see this will be, so 7 into 5 is 35. 35 into 120 is there, right? So if you calculate, so you will get 4,200 you'll get, right? And the same way, if you calculate this one, 7 into 3 into 5 and 21 into 5 is how much it will be? 21 into 5 is 5, so 105. So 105 into 120 will be around 12,600 you'll get. 12,600 you'll get, right? Okay. 12,600. If you add all the things, what will get? 16,200 and 16,800 you'll get, right? 16,800 you'll get, right? Okay, fine. So that means the beta will be what? Beta is equal to 16,800. Then we'll have idea. What is the idea here? How to find the number of onto function, that is beta, right? How to find out? So just 7 books you consider, you 5 boys you can take. Yeah, 7 books you have to distribute among the 5 boys. At least one students get at least 1 book, right? That is the logic for the onto functions, because every pre-image has every element in the codomain. That means the number of boys having the pre-image in this, right? Okay. Let me take that that page. You can see what we discussed, the alpha here. So alpha is what? Alpha we discussed that 2520, right? 7 into 5 into 6 into 4 into 3, right? So here is the 5, here is a 7. So if you take 1, 7 choices there. 2, you can see alpha how to calculate. You can see 1 you have 7 choices, A2 have 6 choices, and A3 5 choices, A4 4 choices, and A5 3 choices. The total, if you calculate, 2520 you will get 2520. Clear? Okay. So therefore, what they're asking actually, they're asking what is the 1 by 5 factorial into beta minus alpha. So 1 by 5 factorial is 120. So beta already calculated 1680 minus alpha is what? 2520. If you calculate this one, then what will get finally? Answer is 608 16,800 minus 2,520. How much it will be? 14,280 will come, right? The final answer 14,280 divided by 120. That is your value. That value is 119 will come. Okay. I hope everyone understands this. 1480 is correct or not? You can see 10 is correct. Is 8 correct? For yes, 14,280 is for your beta minus alpha, and 5 factorial is 120. If you divide 119 is your answer. I hope everyone understand. Let's go for the next question. You can see next question is this one you can take. Which one you can see here? Yes. So A is given to you 1, 3, 7, 9, 11. B is given to you 2, 4, 5, 7, 8, 10, 12. Then total number of 1 map they're asking. You can see here is 1, 3, 7, 9, 11. Here is, this is A, this is B, this is 2, 4, 5, 7, 8, 10, 12. Okay, then you can see that f of 1, f is mapping from A to B, f of 1, you can see f of 1 plus f of 3, the image if you add it, no, you will get 14. This is only possibilities. You can see 2 plus 12, this will be, you'll get 14, and then 4 plus, you can see this case, 4 plus 10, right? 4 plus 10, you'll get 14. There are two possibilities only is there, right? But 1 function means what? Every distinct element has distinct images, right? Okay, so there are two possibilities there. You have to set two out of that. You have to select one, right? Because if 1 means one distinct element has distinct image. Out of two, you have to select one. So there are two possibilities there, right? Each would have two possibilities there. If you select one, either you can goes to 2, 1 goes to 2, or 10, right? Or if you take 3, 3 map to 4 or 10. So two possibilities there, right? If a 2 number is mapped actually, okay, then f of 1 is mapped, f of 3 is mapped. So how many elements is there here? Total 1, 2, 3, 4, 5, 6, 7. If 2 is mapped, so how many choices for, you can see 1 and 3 only you are mapping, you are taking, right? 1 and 3. The 7 has how many possibilities there? If a 2 is mapped means remaining 5 element is there for the 7. 9, how many element is there? 4. And 11, how many elements is there? 3. That is your possibilities, because distinct element has distinct images. So you can multiply this, what's your answer? 2 into 2, C1 it is 4, into 5, into 4, into 3 is 20, 20 into 12. How much it will be? 20 into 12 is 0, 4, 0, here it is 2, so 240 is your answer. I hope everyone understand, right? The image, we need only the sum will be 14. That means 2 plus 12 is 14 and 4 plus 10 is equal to 14. There are two possibilities there, right? F of n is either goes to 2 or 10, or 3 goes to 4, or you can see 1 is goes to 2. F of 1 is what? 2 means, and then f of n either goes to 12. That means 2 plus 12 will be 14, or 3 goes to 4 or 10. So there are two possibilities there. In that you have to select one. Why we are choosing one? Because distinct element only is there. You cannot choose two at a time. That it will not be 1 functions, right? You have to select one. There are two possibilities there. Either 2 plus 2 plus 12 or 4 plus 10. Two possibilities there. You fix it for the 1 and 3. Two possibilities. Remaining 7 is there. 7, how many element is there? 2 fixed image. Then 5 possibilities for the 7. 9 is there, no? 4 possibilities there. Why we are taking that? Because distinct element is required, no? That's why. So 11 has 3 possibilities. There are 240 number of 1 functions possible. Number of mapping, 1 mapping is what? 240. I hope everyone enjoy this class. So this is completely 1 onto functions, one shot video. So if you like this video, so please subscribe my channel. So you can share to your friends. This is coming days. This exposures will help you for your JEE main and advanced. Okay, I will teach you step by step everything with a example. Okay, so thank you everyone, students. Thank you everyone. So please subscribe my channel. Thank you.